Hello, are we ready for some math? Am I ready for some math? This is going to be a process of getting some cobwebs off of our brains, myself included. So I hope you guys are doing well. Please read the announcement very carefully that I posted right before this video. And I will talk to you guys live on Wednesday. So make sure you read that announcement. Take a second and pause to copy down these identities. I can't just sit here and wait. So I'm going to suggest that you guys pause this every time you have to copy something down. I may not remember to remind you, but you guys are smart enough to do that. So these are identities that we learned in Algebra 2. So take a second to pause. Okay, so hopefully you have these memorized. A trick that I have for these, for some reason it helps me to remember that the cotangent has a cosine on top, then therefore the tangent does not. You then have to kind of remember the general idea of these, but if you can remember the two and you don't remember which one's which, that has always been helpful for me. You guys all know the reciprocal identities. I feel pretty confident. They're kind of redundant here. Obviously, these two mean the same thing, and these two mean the same thing, and these two mean the same thing. And then even odd properties. Usually I would show you why these are true, but I want to keep the notes as short as possible, so I'm not going to show you why these are true. It's a pretty simple, proof, and you can find it in your book or online somewhere. So I'm going to just leave those for you to remember and work with. These are things that we have to have memorized. We're going to be using them throughout the second half of chapter 7, which is what we're starting now. Pythagorean identities, though, I do want to show you what I do, or what I used to do when I first started teaching trig. Because I think everybody can remember sine squared plus cosine squared equals 1. That's pretty straightforward, and I think that's pretty embedded in our brains. The other two are a little bit more difficult to remember. We're like, there's something with tangent squared, but I don't know what it goes along with, and there's like a 1 plus, and what goes where. So the way that I used to figure out those, I would always remember the sine squared plus cosine squared. And then each time I would teach this for the first time, maybe for the first couple years that I was teaching, I would have to kind of work with this to figure out the other ones. So I know there's like a 1 plus and I know there's a tangent. So I'm thinking, okay, the way that I can figure out the other two, there's two more in the Pythagorean category, is just by starting to divide. If I'm dividing, I have to divide everything by the same thing, right? And then I see this is 1 plus cosine squared over sine squared using this identity here, cosine over sine. So cosine squared over sine squared is going to be cotangent squared. And then 1 over sine squared using this identity is going to be cosecant squared. So that's the second. The order doesn't really matter, but. And then I can get the third one, again, starting with the one that's easy to remember. But instead of dividing by sine squared, I'm going to divide by cosine squared. And again, pause me whenever you need to pause me if I'm writing too quickly. I don't want to slow down in terms of the writing because I don't want this to be incredibly long. Sine squared over cosine squared going up here, that's tangent squared. And then that's 1. And then 1 over cosine squared, you guys all know that's secant squared. So that's the third of the Pythagorean identities. Okay? All right, so take a second to copy down whatever you need to. Pause me. I'm not going to wait to copy whatever you need to from here. Okay, so we're going to be verifying identities. Now, I'm not going to read through these guidelines yet because we're not going to do this until, oh, this is actually the second day. Darn it. Okay, well, keep these handy because I just realized that I wrote those down and we're actually not going to use them today. I'll have to, you might be using them in the homework, but we're taking baby steps. So we're working towards the verify the identity problems that everybody loves in Algebra 2. Sarcasm. Right now, we're not given an equation, we're given an expression. So generally what we're working towards is being able to take a trig, an equation that has these trig functions in them, and confirm that the left side equals the right side. So baby step, we're going to focus on just one thing, not an equation. They want me to write it as one trig function. So these are going to come in handy for us. It's just we're not going to, number 2 isn't going to come into play until we were talking about equations. Also number 1, there's no side. We're talking about sides of the equal sign here. Usually it helps to change to sines and cosines. So I want to think about tangent. I'm going to use the identity above and I'm going to turn it into sine over cosine. And then cosecant, I'm going to use the identity above and turn it into 1 over sine. And now you all see what's happening. I can get rid of that. And that becomes 1 over cosine. Now that is one trig function, but I can write it in a more simple form. Anytime I can write something in a more simple form I want to, I would never put 2/4 as an answer on a math question. So 1 over cosine is secant, and I've written it as one trig function with no other operations going on. All right, let's look at example 2. It's really weird teaching without having any interaction. Okay, multiply and simplify. So this is going to be something that's going to be really common that we're going to do when we start doing these verify the identities where there's equations. This is kind of like the conjugate where the plus sign in between is the opposite of the minus sign in between, and we're doing it on top and bottom. This is the problem, by the way. This is, I'm kind of getting ahead of myself here, but a common strategy in simplifying things is multiplying by what's kind of like the trig equivalent of a conjugate. So the only tricky part is I'm going to not distribute on top. This is going to come with practice. Recognizing that if I distribute on top, that's going to get really complicated. I'm going to have a cosine times a sine, and that's just going to be yucky. Once you see this a few times, you're going to see that if I FOIL out the bottom, I'm actually going to get something that's more simple. And again, like I said, this is going to come with practice. So first times first, outer is plus sign, inner is minus sign. That's going to cancel out. Pause me and rewind that if you need to hear that again. And then last times last, sine times sine is sine squared, and it's a positive times a negative. Now, one thing that we need to get good at with these trig identities is not just seeing, particularly the Pythagorean, not just seeing them in this form, but seeing them in another form as well. So this is equivalent to 1 minus sine squared equals cosine squared. Do you agree? So what I'm saying is I'm going to use this 1 minus sine squared equals cosine squared to turn this denominator, hold on, let me rewrite the numerator. 1 minus sine squared, we just said that equals cosine squared. So what I've done is I've FOILed this out and I've gotten myself something more simple. Not only that, but I have a cosine squared and a cosine. I can cancel out this cosine with one of those cosines. So then, excuse me, I can write 1 plus sine theta over cosine theta, right? That's gone in the top, so I'm left with this parenthesis. And then at the bottom, one of the cosines canceled out, but there's still one cosine left. Now, when we're doing verify the identity problems, that might be where we stop, and you'll know, trust me. Just trust me on it for now. The back of the book on these problems might write it differently. I can split this up into separate fractions, these have a common denominator, so I could smush them together to equal that. I'm allowed to go forwards and backwards in math, right? I'm running out of space here. And then 1 over cosine is secant, and sine over cosine is tangent. Okay, last example. Rewind and listen to that again if you need to. Last example. Trying to keep these videos to 15 minutes or less. Let's see if I can do that. We're at 10 and a half. Sorry, I can't freeze the overhead like I normally do so that you guys can copy while I'm writing. Okay. So pause me for a sec if you need to finish writing that. I'm going to jump right in. Common denominator, we know what a common denominator is. They need to have the same denominator. This one has a cosine and this one has a sine. They both need to have a cosine and a sine. That's the only way to get them to be a common denominator. If I give this guy a sine and I give this guy a cosine. But you all know that we can't just do that. We can't just multiply wherever we want. If I'm multiplying an expression, I have to do it on top and bottom so that I'm multiplying by something equal to 1. So I'm going to multiply just like this. The cosine over cosine equals 1. I haven't changed the value of this fraction. Sine over sine equals 1. I haven't changed the value of that fraction. So I want you to take a second and see if you can guess what I'm going to do next. Okay, I'm going to distribute. Maybe you got that, maybe you didn't. Sine times sine is sine squared. Sine times cosine, right? Distributing here. And then I've got the plus. Cosine times cosine is cosine squared minus sine times cosine. And then my common denominator was that. And then now you're all seeing that sine cosine and sine cosine goes away. And hopefully you're seeing sine squared plus cosine squared equals 1. This is why it's imperative to have these memorized. Because if you don't have these memorized, it's going to feel like a foreign language. I'm going to be speaking a totally different language to you, and that's not fun. So sine squared plus cosine squared equals 1, and that's all I have left on top. I'm turning this into 1. These two things went away. The denominator I didn't do anything with. The sooner you have those trig identities memorized, the easier this chapter is going to be. And it's the entire rest of the chapter, just FYI. And then again, sometimes when we're doing the verify the identity problems with the equations, we'll leave it like that. Probably not on this problem. So I can break this up, just like I did the last one. Before you start breaking things up, or maybe break them up in pencil, because that's what we do our homework in, right? Break it up in pencil, and then check and make sure that it actually ends up being that same thing if you put it back together. Same thing for this one. If I break this up, I want to check and see if I add these together, is it going to end up being that same thing again? So make sure it works in both directions. Common mistake that people make, particularly with addition, they'll do something like this and try to break it up. And if you look at that, that's not going to smush back together to make that. You would have to give this a common denominator. Okay, so check and make sure it works both directions before you move on with the problem. That one does. I would multiply top times top, I would multiply bottom times bottom, and I would end up back at that thing that I had originally. And then 1 over sine, knowing my trig identities, is cosecant, and 1 over cosine is secant, and that's as far as I can go. Okay, so again, I'm going to reiterate, please read carefully the announcement on Canvas that I made right before I posted this video. And I'm looking forward to seeing your faces on a call on Wednesday. I hope you all can make it. And I hope you're doing well. I'm thinking about you. I miss interacting with you guys and being in the classroom and working on math together. I'm now 6 seconds over my 15 minutes, so I'm going to stop.